So what I'm doing is I'm covering in-depth, architecture of BW. So if you are experienced in BW, probably it would be slightly repetitive, but okay, good, very good. So we are covering right from scratch. So in a couple of previous sessions, what I covered was okay then. So let's start with the session now. I will share my screen. I'm sharing my screen, and then if you feel that it is repetitive, just keep quiet and listen to it. If you have any doubts, feel free to interrupt and ask me anytime. It's an interactive session. The objective of our session is to learn. Okay, so you don't have to feel shy or hesitate to ask, even though it might sound a very simple or basic question. We are learning about BW. So BW, as you know, it's a software which falls under data warehousing category. Okay, and it's a SAP software. So SAP did a lot of research and analysis before launching its software of this category. So there were other data warehousing softwares prior to BW, but that were not that popular as BW. The reason being that BW has got its own benefits. We will go through the slides. You will learn and understand why it is superior to other tools in the market and what was the reason. Okay. Before I proceed with BW architecture and other details, a quick recap of differences between uh, reporting in BW versus R3 or SAP S4 HANA, or you can say uh, SAP ECC. Typically, uh, you know that the whole objective of any data warehousing software is to store the data in a centralized repository and retrieve the information as and when required. And the way the information is accessed is in the form of reports. So at the end of the day, the final product which our client or customers of BW are interested in is the reports and dashboards which are generated out of the data created in the BW system. Okay, and when we talk about creating or building reports, we also had flexibility to build reports in SAP S4 HANA or SAP ECC version or the prior version of ECC, which is SAP ERP R3. Then why do we need to have a duplicate set of tool to create again same objects which can be created in other tool? So here are the differences. The differences shows us what's the benefit of reporting using BW software compared to R3 or S4 HANA. So what we can do is in R3 we can do line item analysis. So this tool is typically meant for reporting at a very detailed level, whereas BW is, as I mentioned, is used for reporting at a segregated level. Okay. Now, the reporting in R3 is usually two-dimensional. You cannot drill down further into detail levels. Whereas here in BW, the beauty about any data warehouse, not only BW, if you go for other data warehouse tools as well, we have the flexibility to go for multi-dimension data analysis. We will learn about this, what is multi-dimensional when we create the report. You will be able to understand it when we practically look into the objects once the reports are created. I will walk you through and then explain you how and what way these reports are different to R3. Okay. Likewise, there are some standard reports which are delivered out of SAP uh, ECC or S4 HANA as well. And along with the reports in S4 HANA, we have got some newer concepts which are not there in this particular slide. They are called as Fury apps. So these apps are pretty handy and useful. Um, and there are lots of functionalities and reports which can be achieved now in S4 HANA using Fury. So there are standard Fury apps, hundreds of apps which are delivered by SAP, which can be easily consumed or utilized by S4 HANA clients. Whereas in BW also, we got a flexibility of certain using out-of-the-box reports. These are called as delivered reports, and they are delivered in the form of something called as, the terminology here is business content. So there is a topic in itself called business content. We will cover that as well. So there are lots of objects which are delivered by SAP, but uh, they are in a compressed or zip format. We need to uncompress or uh, activate them in order to use it. So we will learn that when we go through the topic of business content in detail. So the benefit is we got standard reports in both, but in BW we got some additional standard reports which are not there in R3. So these standard reports means are these reports, the meaning of the standard reports or delivered reports is that we have out of the box reports, which means you don't have to create from the scratch with very little or minimal effort. With very little or minimal effort, we can create these reports in BW. We will see that how it is possible. Okay. To create reports in R3, we need we need someone with the technical skills, programming skills like ABAP language experience. Whereas in BW, you don't really need to know ABAP at a full-fledged level. You can, so in for BW, we don't need to really know, I mean, it's like there is a bit of ABAP skills required in BW as well, but not to the extent of what is required for creating the reports in uh, S4 HANA. Likewise, S/4HANA reports consume data from the transaction processing. They are slightly, you know, detailed. Whereas here we get the aggregated data, so the processing is slightly faster. We have real-time analysis. Sometimes here in BW, we bring the data overnight into the BW system, so we don't really look into up-to-date data, but with HANA database, it is feasible. You can also now look data into real time now. So this is changing, which means that you really don't have to wait for a complete day to see the uh, data in BW. So usually what used to happen in BW was we used to load the data from S4 system or ECC using the nightly batch job, and using that job we used to trigger the data load from R3 to BW. Whereas now there's a lot of improvement due to which we can then get the real data in real time in BW as well. So typically R3 reports are specific to a function, whereas BW are cross-functional. So which means you can see the data in BW from one report can have data from multiple functional areas. Now, I think we have seen this briefly. The business warehouse is a SAP's architectural solution for data warehouse. As I mentioned, it provides seamless integration with R3, ECC, or S4HANA. It has got built-in functionality that reduces the design and development effort. Okay. As I mentioned, this is a separate system. So it is an additional system on top of your S4 HANA system. Okay. It's a separate individual isolated system, which has got its own uh, architecture, landscape, hardware, and data set. So in BW, most of the time, the preferred way of reporting via BW is to extract the data, persist the data into BW, and then create a copy of the data into BW and then report from that data set. Okay. Uh, Next one is the R3 data structures are optimized for according to different. Okay, let's move on. So before I proceed further, is there any are there any doubts or any clarifications needed? Okay, so we will go through the system landscape of BW again in subsequent slides as well. I don't want to confuse you. This is one of the example of you know, the landscape of BW. It's slightly complicated. So typically, if I want to simplify it, just ignore the last two boxes. So just concentrate on first, second, third. So these three boxes. So basically, I would suggest that you bring the data from R3, which is S4 HANA, into BW. So the way the systems are connected is we have multiple system landscape. Typically in the landscape, there are development systems, there are quality systems for testing, and there's a production box. So the production system contains the actual real data. Development system is used to develop the objects, move the objects from one system to another system, do the testing in that way, QA system, which is quality assurance system or test system. And then once it is passed, then it is moved to the production system. So we'll go through the landscape again. The same landscape is followed in BW as well. The way the systems are connected is at the same level. For instance, the dev of S4 HANA is connected to dev of BW. The QA of S4 HANA is connected with QA system of BW. Likewise, production of S4 HANA is connected to the production system. Production system is the main system. The actual business runs on the production system. The business users access the production system to access the data. Development system is used by developers like us. Product quality system is used by testing people. Okay. Now let's deep dive into the objects of BW. These objects are not relevant anymore because this slide is from the previous version of BW, but there are some newer objects which are there in BW for HANA. We will learn that, but it is the purpose. This slide is intentionally kept so that you are aware of what was there in the previous version. If someone asks you, you should not be felt blank, and that's the objective. We are covering bit of topics related to the previous version of BW as well. So if you have worked on the previous version, then for you it might be slightly repetitive, but for those who haven't worked on the previous version of BW, for them it would be helpful because they would then know that uh, concepts which were there previous in the previous version. Okay, so the BW system is connected is, say, the yellow box here is the source system box. Okay, so the data sources are the sources or the tables which are connected from the source systems, and they are used to establish a relationship between the source data to the target data. So here the center part is the BW system. The left part, just to keep it simple, we have say S4 HANA system, and we have non-SAP system. So you can connect data, you can connect BW system to any source system. Not only S4 HANA, it can read from other Oracle-based systems or other ERP systems or Excel-based flat files, uh, web-based portals. You name any type of media, it can be connected to any type of software or media, and then there would be some way or the other way to extract the data from that source into BW system. As I said, in most of the cases, the BW system is used as a central repository to store the data centrally. Hence, it is also called as a EDW system, which is Enterprise Data Warehouse System. You bring the data from various sources, store it into the BW, and then build reports on top of it. Likewise, here in this particular example, we have on the left side some source system, on the right side we have BW system. We have first layer of object in the BW system called as ODS, which is known as operational data store. It's a raw data repository. Typically we used to store the data in the ODS, and then from there we move on to the multidimensional data store. So ODS is a two uh, it's a flat table type structure, whereas InfoCube is a multidimensional structure. We will learn about the differences between both in the subsequent slides. So for the time being, we just have to interpret in such a way that we bring the data from here, store it into one database or one type of object, one table, and then from there we move on to the copy the data into another layer of data sets into another cube or another table. Just uh, in layman terms, I would say that, okay, these are different types of tables. So you store in stage wise or phases wise into the BW system. And once the data is there in the InfoCube, you then have a virtual data provider called as in multi-provider, and then from there we create reports. But in S4HANA, this has changed. We will see what has changed. So these have been replaced with ADS. So there is only single object. We don't have to have multiple objects in S4HANA. They have simplified it. We will see about the changes in the architecture when we learn about S4HANA topic. Okay. Now, from the architecture perspective, as I said, BW is mainly used for creating reports. The way the data is flown into the BW system is the first layer has got the ETL layer, which is extraction, transformation, and load layer. So what it does is using the ETL layer, you can connect to any source system, and that source system we can connect to the tables of the source system. From those tables, we can connect to the fields of those tables, and then extract the data from that respective source system using the ETL mechanism into BW system. So in the BW system, using the extractors, which is ETL, we pass the data and store in the storage services like InfoCube or ODS. From there, we pass on to the analytical processing services like use the BEX query analyzer, or here in the BW for HANA world, it is called as BW query. And from there, using the analytical engine, we push the data into the next layer of reporting tools. Like we used to use business objects, or uh, in the very old days, we used to have something called as web application designer or BEX analyzer. But these days we have something called as business objects tool sets. So we have the presentation services, which is BO tools like Webby, Crystal, Lumira. But now everybody is moving from that as well to a better tool, which is SAP Analytics Cloud. So finally, the presentation layer is moving on to the cloud-based application. And we have some administration services to manage the system. We have metadata services. What those are, we will look into them in detail at a later stage. This was one of the tool we used to use in the olden days, which was called as BEX Query Designer. Now they have renamed it. It is called as BW Query instead of BEX. There are slight changes to the look and feel of the tool, but we still have the similar tool to we used to create the queries or reports. So the once the data model is created in the BW, we use this tool or similar tool to create reports for BW. So these are not reports, but I would say, to be precise, we create something called as queries. Then those queries are published into a particular reporting tool. Is it okay so far? I can repeat that, and obviously we will come across these things several times during the course. So if you miss also, don't worry much. There are subsequent repetitive slides across the modules, and when we cover that module in detail, we will cover again. So in short, just visualize like this, that the key tasks which are involved in creating a report in BW are, I would say, divided into 4 different categories. One is we use some tool to extract the data, which is ETL services. Okay. Once we extract the data using a particular tool, we have to store it somewhere. Okay. That's the storage services. So we persist the data, or we physically create a copy of the data into the BW system. That is storage services. Once we have that data in the BW system, then we have to expose the data to reporting tool. That exposure of the data to a reporting tool is done using an analytical processing OLAP tool, which is, I would say, your OLAP tool is BW query. Once you create a BW query, then you expose that query to front-end reporting tool. These days, the tool which is very widely used is SAP Analytics Cloud. So we use actual presentation tool like SAP Analytics Cloud, or business objects reporting tools, such as you can use web application, Webby, web intelligence. You can use Lumira, you can use Crystal reports. Not only SAP related tools, You can also use other front-end reporting tools like Power BI, Tableau, Click, ClickView, etc. So lots of options are there for generating the BW reports. Okay.
Okay.
And this is the just to give you a bit of look and feel to make you familiarized. This is just a screen. We will obviously just if I spend even 10 minutes on this screen, you will not understand much. But when we do the hands-on practical, then you will understand and appreciate the features of this particular tool. So your BW query tool might look similar to like this. So this is again, Bex Analyzer is not used anymore. We are using other tools. So we will see that, but this was the predecessor tool which we used to use in the previous version of BW. It is just for you to understand that we have we had a very good tool in the previous days uh, for accessing the queries or reports, and that was Bex Analyzer. It was a what do you say? For accessing the Bex Analyzer, you need a hard client, which is you need to have a software, special software installed on your machine to access it. It was not using the um, web-based browser. Okay. In my previous slide, I have also mentioned about business content. We will go through this particular topic. It's a big topic in itself. As I said, the biggest selling point of BW was that it had got a feature to quickly deliver and build reports in BW compared to other tools. So you had a feature which was very powerful to uh, build reports with very minimal effort. We will go through this feature in detail, that is called as business content, in our subsequent slides. Okay. What is the benefit? What are the benefits of going for BW reports? They are very flexible. Uh, you can add or remove objects easily. You can also analyze historical data, trend analysis, forecast. You can also use with a planning tool. So all these are the benefits of BW. Now, what are the different versions of BW? This is the history of all the versions we had in the BW space. SAP changed the name few times. I have not changed it here. In between, it started with BW, then I think then it changed to BIW, then changed to BW, then from 7.0 it changed to BI, just BI, and then BW for HANA 1.0 and BW for HANA 2.0. So these are the different versions of BW which were released by SAP over a period of time. And these are the timelines when those versions were released. 1.0 version was released somewhere in 98, 99 1.2, 2002.x. So I have been working from, I have seen, I believe, little bit of 2.0b, but from 2001 onwards, I have been looking into this software. I have seen lots of changes, and uh, the best I would say is BW for HANA because it has oversimplified it. It is very powerful compared to the previous versions. The effort to build the objects and maintain has been significantly reduced. So now you can very quickly build uh, objects, same objects in BW with very less effort compared to the previous versions. So definitely it's a very good progress with regards to software. Okay. Now, deep dive into key terminology. We will use this terminology a lot. So now, basically in SAP BW, we build reports. So report is actually a set of data, right? So the data which is reported in a report or displayed in a report is categorized into primarily into two categories. So the data which you see in a report can be broken down into two major categories: numeric data and non-numeric data. I would say numeric data is something which has got numbers in it, and non-numeric data is the descriptive data. Okay, so the numeric data in BW terminology is called as key figures, and non-numeric data is called as characteristics or the descriptive data. Now, for instance, what would be the example of a numeric data? Say, say you have a bank account, okay? Your name is a numeric characteristic, is a non-numeric data, sorry. It's a characteristic data. Whereas your bank balance, the amount balance in your account is your key figure data or numeric data. So likewise, if you see a report, you have say customer details, you have product details, you have material details, you have uh, say vendor details, like vendor vendor uh, vendor name is there, then you have, you know, outstanding amount to a vendor, accounts payable, okay, amount, balance, outstanding balance, okay, tax. So these are the numeric values, they are key figures. So in BW, the data is classified into two types: characteristics and key figures. Okay, do you understand the difference now between a characteristic and key figure?
Yeah.
So for instance, this is another example of a multi-dimension data model, and this is the way how the data is typically classified and managed in a data warehousing system. This is an example of a star schema. So it looks like a star, something center and then uh, surrounded by several dimensions. So this is called as a star schema, wherein you have a fact table in the center surrounded by several dimension tables. So these are different dimension tables: area manager, controller, top management, product management. These are the dimension tables surrounded by a central fact table. Okay. So these are the characteristic data is stored in a separate table, and key figure data is stored in a separate table. This is another example of characteristic versus key figure data. The characteristic data here is like you have a time dimension. The data is displayed quarter wise, fiscal year wise, attribute wise. We have a product dimension. Data is displayed like, you know, current account, okay, overnight savings, sales data, location, organization, customers. This is actual example of star schema, one fact table surrounded by several dimension tables. So again, if you see here, we have region, we have customer number, customer group, quarter, month, fiscal year. All these are the characteristics. Okay. Now the key figures are here, like customer total sales, total discount, number of items. Now these tables, which are characteristic, their key is stored here in the fact table. So this is called as you know, fact IDs, or we have something called as in star schema, we have a fact table which is central component of a design, which has got actual actual key figure values like total sales, total discount, number of items. All these are the numeric values surrounded by several dimension tables. Each table contain, you know, relevant data for those specific set of characteristic values. So a fact table surrounded by several dimension tables is called as a star schema. BW took it to a next level, and it said that it has got something called as extended star schema. Uh, Again, this is not probably in the next session. Maybe I will give you a better example of how the extended star schema looks like. So we have had that extended star schema in the BW, through which the data is organized in much more easier fashion and is maintained and retrieved easily. Okay. So the disadvantages of the star schema were that the master data is inside the cube of the, so the reusability is reduced. Okay, I don't want to get into this star schema and extended star schema too much. The reason being that the architecture is changed a little bit. But obviously, when we come across the practical session, I will show you like how it looks like um, and what it actually means. Okay, let's move on to the other interesting topic related to BW is the methodologies, the project management methodologies which we use in BW projects. Okay, so it's slightly relevant, but it is not purely technical. This is more towards project management. I am giving you an update on this so that you are familiar uh, with the way the projects are structured in the organization. Okay, so when you work on a project in real time, then someone would ask you, have you used waterfall model, or have you used agile methodology, or SAP Activate or SAP ASAP methodology? Then you should not be blank. You should be, able to answer their queries. That's the reason I'm covering this topic as well. There are lots of slides for your reference I have captured in this slide deck, but I'll go through them quickly to cover the different aspects of project management methodologies. So star schema is a concept of a data warehousing software in itself. Okay, the star schema had some flaws, which SAP addressed those flaws or shortcomings, and and launched its product called BW. BW is having something called as extended star schema. This is not the right picture to show you the example of extended star schema. Maybe I'll just quickly Google and show you how the extended star schema would look like. Okay, so then you can appreciate the beauty of SAP BW's architecture. So BW is based on extended star. There's a beautiful concept here actually. Now, I believe every one of you have got a account, bank account. I believe so, right? You might be familiar uh, with the process of how the bank maintains a account of a account holder. Okay, what what you do is when you go for opening an account, when you go for opening an account to a bank will ask you to furnish certain details about you, right? So for instance, it will ask you to provide your name, address, date of birth, mobile number, email, so on. So these are the details the bank will ask from you. Is it right? So this is basic information about customer, which bank will hold. So for you, you are one of the customer of a bank. So your customer name is nothing but your name. Okay, that is what the bank will ask, and then it will have all your address, date of birth, mobile number, email address, uh, whatnot, rest all information. Like if there is a Indian guy, he will ask like Aadhaar card details, PAN card details. If so, your tax file number, or in US, I don't know what it is called. The tax file number is. So all those details are asked. These details, which are you know more of characteristic in nature, are called as master data. Okay, why they are called as master data means they don't change. Okay, but when you go to a bank, you 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 do a lot of transactions. You do lots of transactions in a bank, right? When you go to a bank, you do lots of transactions. The transactions which you do are like, okay, you deposit money, say you deposit say $100, then you withdraw by purchasing something. say $10, you do one transaction, then you do another transaction of $5. Then say at the end of the month, you get your salary credited, say $5,000 is credited to your account. So it's a credit, and these are like, few of the debits. So what I'm trying to say here is there are two categories of data. One is numeric data, another one is descriptive data. So this descriptive data is usually fixed. It is not changed. Okay. That is the reason this is called as master data, the characteristic data. And the data which is frequently changed is your transaction data, the way you do the transactions. And the type of data set which falls under transaction data is key figures mostly. Okay. So the transaction in a bank could be like this. The entry could be, okay, it will not have just the customer name. Along with the customer name, when the bank creates your account, you will have bank account ID. It's nothing but the customer ID. Customer ID. That is your unique reference. Typically, bank will not recognize you with your name, but it will recognize you with your what? Account number and your BSB number or the bank number. Or in India, it's IFSC code. In US, I don't know what it is called, the bank code, whatever it is. So there would be a bank code and then the account number. Bank code is common, but typically a customer of a bank is identified using his account number. So when you do the transaction here in a bank, so the bank server would say that, okay, the customer ID would be 000123498. Then transaction type debit $100, and then transaction date, say 21st of August. According to US, I will put it different way, 21st August. This is the way SAP recognizes the date. So this example here is an example of a transaction data, whereas the master data is like this. Customer account, customer name is say Mr. X, address is say something, and then date of birth is something, mobile number is something. So this example of this data is that when you create a new account, your master data details are asked only once. Once the account is created, you don't need to furnish your details again and again to the bank. You don't need to type all your details like your address, phone number, mobile number, email address, all those things. You don't need to do it. Only thing what you need to do is just tell the banker your customer ID or the account number, and then he will do the rest. With your account number, he will identify you as a person, and then it will tell you your details. Is it clear? So now the data is of two types. The gist of the story here, this story seems to be very interesting, but it's not a story. So the message here is like this. The data is broadly classified into two types: transaction data, master data. Typically, the volume of master data is low, transaction data is high because you do multiple transactions on a daily basis. Okay. So master data is mostly characteristic data. Transaction data is mostly numeric data. Okay. Now this is one part of the story. The other part of the story is, if assume that there's another example of transaction, which is like this. Here within the transaction data set, here we have example like this. Okay, customer ID is CID 0023. Okay, then customer name, sometimes in the transaction Mr. X, then transaction type, say debit, then transaction amount, say it is 100. Okay, now if you see this particular example, customer ID is 1. Okay, then customer name is 2nd, transaction type is 3rd. Okay, transaction amount is 4th. So there are 4 different fields. If you classify this data, or if you convert this data into table format, the table consists of 4 fields. Now, the first field, customer ID, is a characteristic data set. It has got characteristic. The second field, name, again, it's of characteristic data set. Then the third field, transaction type, which is debit. Again, this is characteristic. And transaction amount 100 is key figures. So each field in a table, if you talk about a table, each field in a table is classified into characteristic type or key figure type, characteristic or key figure. Okay. Now, majority of the times, the master data falls under characteristic data set. The fields of master data are characteristic. So in this particular example, what are the fields of master data? So what are the fields I've mentioned here? Above master data fields, which are listed above in the above example. What are those? Customer ID is one field. Then customer name, date of birth, then address, and so on. Correct. So all these are the master data fields. So these are the attributes of a customer: name, date of birth, address, phone number, zip code, email. All those are the attributes of a object, primary object, which is customer. So the data, the master data, is again further classified. So the master data in data warehousing world is classified into 3 types. So we are now getting into actual core BW. Before we get into the BW, we understand the data behind it. You need to understand it thoroughly so that you can then build your objects accordingly. So the way you need to understand is, you need to understand how the data would look like, what the data is, in what way the data is classified. Okay. So again, if you talk about the master data, in data warehousing world, the master data is further classified into 3 types: attributes. So the one we have seen on the left side are the master data fields. So these are typically the attributes of the master data, example of the attributes. Then the second type of master data is text table. And the third one is hierarchy. The data is displayed in the hierarchical format. So how the master data is displayed? The master data is further subdivided into 3 categories. Okay, and each category is stored in a separate table. So attributes table, the attributes data is stored in a separate table called as attributes table. The textual data is stored in a separate table called as text table, and hierarchical data is stored in a separate table called as hierarchy table. So the way the data is grouped is that the master data and transaction data. The transaction data is there in the schema, and the master data is again further subcategorized into three categories: attributes, text, and hierarchies. The way the star schema had master data was that there were flaws. The major flaw was that the data, master data in the star schema, was not reusable. If you had assumed that, imagine you had another, instead of customer, you have another table. Okay, here instead of customer, you have, suppose, the vendors. So instead of customer, assume that you have vendor here. Then this data is again repeated in separate tables. So the way the star schema was designed was such a way that the fact table contains the facts or the key figure data, and the dimension tables contain the characteristic data. So for each type of characteristic, there was a separate dimension table. Now we have date or time dimension table, we had product dimension table, we had sales type dimension table, location dimension table, organization and customer dimension table. Likewise, if we have, okay, this is customers. Okay, customers, I don't know to change. Okay. Now in this one, we have vendor. Now, rest all dimensions are same except one vendor. Rest all are same between these two different schemas. Now the data was duplicated into multiple tables in star schema. BW overcame that shortfall which was there in the star schema of data warehouse by introducing something called as extended star schema. Okay, we will go through it again now in the subsequent slides. What does extended star schema means? So before we go for extended star schema, let us understand the data. The data is classified majorly into two types: transaction data and master data. Transaction data depicts the transactions which are happening. For instance, you go to a shop, say Walmart, and buy something. So for Walmart, you are doing some purchase, which means that you are generating a transaction. You log on to Amazon and place an order. Amazon might have your Amazon Prime membership details. So the Prime membership details which you filled while creating the membership was your master data. But when you place an order on Amazon, it's the transaction data. So you have to, how many times do you have to fill the membership details? Only once. But how many times you can do the transactions? N number of times. Whenever you want, you can hop into Amazon and then place an order for whatever you want to purchase. Okay. So transaction data are related to transactions. Master data is related to master data is related to, say, one-time data recognition. Okay. So now to store the master data, we have separate tables called as master data tables in BW. So in BW, the data, master data is subdivided or further classified into three tables. Whereas in star schema, the master data is stored in one table. So here, the master data belonging to customer is, all the master data is stored here in the customer dimension table. The master data belonging to an organization is stored in a organization dimension table. What BW did was, BW took the master data out of this dimension table and further created 3 more tables and stored the data into those 3 tables: text table, attribute table, and hierarchy table. Okay. We will see the subsequent slides. Not sure how clear or visible this slide is. Now this is looking a bit more complicated to you, but don't get panic by just looking into the picture. We have fact table here. We have dimension tables. Dimension tables contain the characteristic data. Now, the way the data is divided in BW is, assume that there is one schema. Here we have got another schema. Now, assume that there is some master data which can commonly used, which is common across both the schemas. So there is one customer, there is one vendor. So here is a customer star schema, here is a vendor star schema. Now there are certain tables which are common across both the schemas. So you can reuse that if you take the master data outside the star schema. So you place the master data into separate attribute table. Here is attribute table. Okay. We have text table and hierarchy table. So you use a separate text table, attribute table, and hierarchy table to store the master data outside the star schema. Now the same text, attribute, and hierarchy tables can be used in both the schemas. Now there's something more to it. I'm not sure whether you guys are familiar with something called as referential integrity and say foreign key and uh, do you know about database wherein uh, primary key and foreign key concept or referential integrity concept of databases? Based on that, okay, um, how do I say? You have a website, okay? You place the address of website into one hyperlink in one image. So if you access the website through one location or another hyperlink, you will still be pointed to the same website. So here is the concept of commonality. We are using the common objects rather than repeating them, duplicating the data. We are avoiding the duplication and redundancy in extended star schema. Now the things have changed slightly here in the BW world. I don't BW for HANA world. I don't want to get extensively into it, but this is the way the star schema is changed. We have the concept of another example with the navigation attributes in place. We will see that when we create the navigation attributes. So this is another example of how the extended star schema look like. Here is the fact table, which are connected with the dimension tables. The dimension tables references are called as DMIDs. They are maintained in the fact table. And each of the dimension table has got again a connection with the SID table. That SID table will link with your, SID table will link to your text table and attribute table and hierarchy table. So this is the way the extended star schema functions. You have text, attribute, and hierarchy tables separate. Now, if there is another, assume that on the right side there is another schema, then you don't have to create the data separately again, repeat again in the same in the table. You just give a reference to it. Now, if I have to simplify in my own way, I would give you a very simple and easy example to interpret this. This should, I believe, clear all your doubts. The explanation which I am trying to give you now, okay, should help you out to understand the complete message which I was trying to pass. Okay, here we have information about customer table. Okay. We have vendor table. No. Say this is a finance report. Assume that this is a finance report. This is a sales report. In sales also, you have requirement to report on customer data and vendor data. So you have requirement to report on customer data and vendor data in both the reports. There are two reports, finance report and sales report. So in the customer data, what are the details you want to see regarding related to customer ID? Okay. You want to see his name, customer name, customer address, date of birth, so on. Likewise, the vendor ID, you have information related to vendor ID, vendor name, vendor type, okay, vendor rating, so on. So all these are the master data related to a vendor. Okay, you have a vendor data, you have a customer data. Now the same information you have to duplicate it here in sales report as well. You need to report it here as well. Same information you need to report it here as well. So now what used to happen was in star schema, you needed to create for each report a separate table which will hold information of customer vendor. Assume that this information is repeated 10 times. You need to create 10 tables. So for each report, say you have a finance report, you have a sales report, you have a purchase report, okay, you have an outstanding balance report, okay, you have advance payments reports, you have you know, privileged customers report, you have top 10 vendors report, you have top 10 customers report. Now assume that you have 8 reports. If you want to capture this information related to all of them is repeated 8 times in 8 different tables in the database. Okay, it is repeated 8 times. Imagine the volume of data. Assume that if each table had 1 million records, you are unnecessary storing the data 8 times, which means 8 million times. Huge wastage of resources, huge wastage of performance. This is there in the extended star schema. Now, what what BW does is BW says that, okay, you don't have to store all this information here. I'll just copy this so that it is easy for you to understand. So now this is the star schema. So this is my way of explaining you the star schema and extended star schema. Uh, and I know the pain. It is not easy. It is definitely slightly confusing for those who are learning it for the first time. But
Yeah,
once you get, sorry,
truly, Ayan, I have a lot of confusion.
yes, I am trying to explain it in such a simplified way. Hopefully, your confusion should be gone in next 5 minutes. Okay.
Okay.
So that is, this is star schema. Now we are going for extended star schema. Now assume that we have extended star schema. The way extended star schema reports or manages the data is that you have this 8 reports. Okay. But what it does is, in extended star schema, this is the beauty of BW and extended star schema. The beauty here is this information, whatever is related to vendor, which is repeated in each report and in each table of the database several times, the duplication is avoided. So the master data in the dimensions table of this one, what it does is it says that, okay, already. Okay. So what it does in extended star schemas, it will just store in the customer dimension table. This is customer dimension table. And vendor dimension table. It will store just the reference objects, customer ID details, and vendor ID details. Rest all, customer ID, customer name, customer address, rest all details are maintained outside here in, this is called as customer attribute table. So it's a customer attribute table wherein the customer information is maintained outside the schema. So this is not a table related to this particular report. This table is outside the data set for this particular report, finance report. Okay. Now, likewise, here also it is the same. So what it does is the data set which is related to a so the data set which is related to a report does not contain the complete information. It will contain only the primary key data information. That's it. Now rest all data is captured outside the schema. So we have attribute table. I will talk about what is contained in the customer text table at a later stage. I don't want to confuse you now. And then we have customer hierarchy table. So there are benefits of having text table and hierarchy table. Likewise, the first table is a vendor attribute table. Okay. Then obviously it has got vendor ID is there. Here we have customer ID as primary object in both customer ID here as well. There are some other fields which are there here in text table and hierarchy tables. I'll explain them later stage. But in short, what happens is we have now vendor text table, vendor hierarchy table. Okay. Now the beauty here is, now assume that this is one report, this is second report. In the previous example, the complete data related to the customer is repeated in 8 different reports. Likewise, like this, if there are 8 times, it is repeated 8 times. Here, even though if it is 8 times, the information for customer ID and everything, we just have only the primary key details. Rest all is just the referencing. So if you want the customer details, it will reference to this one. Okay. Okay. Now we have only one table. Okay. This table here, again, if it needs customer information, you don't have to have a separate table. It will point out to the same, sorry, it will point out to the same table from here. So the data is not duplicated. It is referencing to the same table. So for all these eight reports, the customer master data table, there is only one master data table. Now the benefit of having one master data table is, assume that here, if the data is maintained in separate tables, if there are changes, then you have to update changes at 8 different places. Here, you don't have to update changes at 8 different places. You have to update only at one place. The data is consistent across all the reports. There are no data duplication issues. There are no data inconsistency issues. This is the beauty of extended star schema. Now, the other beauty is with the text table, you can represent the descriptive data in multiple textual languages. Okay, so uh, you can you can display the data in multiple languages here with the text table. With the hierarchy table, you can display the data in the hierarchy format. Okay, so how does the hierarchy look like? I will explain you 1 second. No, I am talking about BW versus non-BW applications.
Okay.
Okay, in BW application, we have this advantage that you can reference what you are talking is right. So in BW, we have the benefit of referencing the data and avoiding the data duplication. You don't have to recreate the data multiple times. That is the main point which I am trying to explain you. The difference between star schema and extended star schema. Okay, the data, the master data and transaction data are stored separately. See, in star schema, the transaction data and master data were clubbed together in same table, and that created a lot of problems. So in one dimension table, we had master data as well as we had transaction data as well. Now the issue with that was that you were duplicating the data. If you embed the master data in one star schema, and if suppose another star schema wants to utilize the same data set, it was not feasible because that was there in one schema. Do you understand the schema concept in the database?
Yeah.
A schema is an isolated sub part of the database, wherein whatever tables are there in one schema are part of that schema. They are not visible with to another schema, right? Likewise, whatever data is there in one schema of BW or traditional BW application was not visible to another schema because the master data was embedded. Now, with the BW, SAP did a wonderful thing by introducing the concept of extended star schema, with which the master data was stored outside the schema, which means that it can be consumed by any schema. Here in this example, you can see that the inner circle is the schema, whereas the outer circle is the extended star schema, which means that now this particular data is open and available for access by any other schema. Okay, so here is the data uh, reusability concept. Here we but are you able to follow? Are you able to follow the session? Is it all good? See, do you know the concept of referencing? So if you have a kind of like one table which needs to be a cell which needs to be referenced in Excel multiple times. So I will give you one more example, simple example. Uh, maybe you can correlate it more easily with this. Okay, I have a table here. Okay, so here I have customer name, customer address, okay, customer phone number, okay, and we have a customer ID. Can you see my Excel? So customer ID, customer name, customer address is suppose, and just to keep it simple. So this is one place wherein the customer information is maintained in sheet 1. Okay, customer sheet. Assume that you have a vendor sheet, and now the same information is there in 2 sheets. Assume that the customer has changed. He's a customer, is also a vendor as well. So instead of customer, assume that he has got, okay, for this argument sake, keep it the same thing. Just hypothetically, customer, okay, yeah, here we will have say local customers, and here we have say global customers. Okay, so now this customer does purchasing of their global products, this customer does purchasing of the local. So the same customer is doing their purchase of the local products and global products. Okay, now assume that the customer changes information here. The phone number is changed from 1234 to 4321. What you have to do is you have to go and come here and then again change it 4321. If you forget it, then the data would be inconsistent. In local customer, it will show you 4321, but if you don't change it here in the global customer sheet, it will show you 1234. So sometimes you will get lost, and then you would not be able to figure it out which information is valid. Whether this is old or this is old, you don't know which one is more accurate. You will not be able to figure it out. If the same information is repeated multiple times, it is always good to make one as a primary one. So assume that you made this as a primary field. Then what you do is you give here referencing. Here instead of writing the information, you just give reference to the same field here. I have used a referencing here. Okay. Now this is a referencing to the local customer sheet. Now here what I do is I go and change here and change it to 9999. As soon as I make a change here, the change is reflected here as well. I haven't changed in the global one. Now if I go and change it to 7777, this is my primary sheet. automatically it is reflected in my secondary sheet as well. This is what is called as referencing. You are referencing to the data and you don't have to duplicate the data again. You don't have to maintain it separately. Likewise, here also you are referencing to the same table. You are referencing to the master data table in multiple locations. Okay, this is the beauty of extended star schema. Every info cube has two types of objects, fact tables and dimension tables. Info cube consists of one fact table surrounded by multiple dimension tables. Info cube needs to have minimum of a maximum of 16 dimension tables, minimum of 4, 3 generated tables, data package dimension, time dimension, unit dimension. So this is all helpful when you get a chance to work in the previous version of BW. But in BW for HANA, the beauty is that you don't have to know all these things. These things are changed by a combined object called as ADSO, advanced DSO. Okay, so it is slightly changed, and this is part of extended star schema. So in classical star schema, the characteristic record is directly stored in the dim table is nothing but dimension tables. For every dimension table, a dimension ID is generated. Whereas in the extended star schema, dimension and master data are different. Master data is stored outside the info cube and dimensions table inside the info cube. In classical star schema, we can analyze 16 angles or perspective, whereas in extended star schema, we can analyze 16 into 248 angles or perspective, and the performance is faster. And there are lots of other benefits as well in the extended star schema. This is how the data is stored separately in the extended star schema. We have a fact table, we have multiple dimension tables, and each dimension table has got multiple extended star schema master data tables. I think I don't want to confuse you too much. Let's park it here aside. Whatever you understood is good. If you're not, then when we do the practicals, probably you would understand a bit more.